Hi, this is Template Podcast, Innovation with Open Source. We want to know what avocados mean to Linux. That's our talk today. We have a special guest, Justin. And Justin, how are you doing?
Doing well. So glad to be here and talking with you all today. It's going to be exciting to jump in and talk through some of this stuff and yeah, pull it apart a little bit more.
Yeah, and with me is my co-host Cliff Brake. How are you doing, Cliff?
Hi. Yeah, glad to be here.
So, Justin, tell us about yourself. What do you do? What have you done in your career so far? And what are you doing these days?
I've had as I would put it, several lives worth of interesting experience. Before I was doing any computer programming at all, I was a musician. I was working in LA in some studios, and this was right around the early 2000s when audio recording kind of made that switch, more hard pivot from analog systems to digital workstations on using computers. And in that time, programming automation effects for like volume envelopes and all the kind of work that you'd have to do to duck out audio for like film and television, it all had this kind of feel clunkiness, like while the software was maturing, that you almost felt like you were a programmer. You had like drawing these automation lines and stuff. And so I really fell in love with the idea of just logical workflow programming automation. And that moment, I took a switch into computer programming. And interesting, simultaneously, I really enjoyed motorcycling, getting out and just kind of using that as an escape. And I wanted to combine these worlds together. And this was now like, probably 2005 era. I had this obsession that I wanted to be able to remote start my motorcycle using my phone, right? And so we're talking like pre-iPhone, all right, Palm Pilots reigning supreme, and Windows Mobile was there. And I remember I took some off-the-shelf components. I knew I needed some like relays. I didn't know a lot. It was at this point really just kind of diving into this part of the career, and I would just stare at schematics of the motorcycle and trying to understand how to integrate with it. And it was a long task, but I accomplished my goal. I took a Windows mobile phone and some like Bluetooth controllable relays, and I even shopped out the parts of the wiring harness that I knew I wanted to disconnect and shim into, so I didn't have to cut it. Yeah, and I got the thing wired up and running, and that I just instantly fell in love with what was possible. But it was blaringly obvious to me at that point that while it was in reach to be able to gain the knowledge to do the hardware aspects of it, and it was within reach to even gain the knowledge to do the mobile phone parts, that really the bringing it all together and making it feel like a cohesive system and function with all of the error cases that the real world provides. That was an area that was tricky, and that's really where I decided I would just kind of dedicate obsessively the rest of my life towards embedded systems. The
Mhm.
ultimate blinky for me was starting that bike.
So yeah, I'm sure that really impressed your friends. You walk up to it, and all of a sudden the machine starts, and yeah, it's pretty neat.
Yeah, I had a programming job at the time, and it was so cool because I didn't stop there. I got that bug, and I had some other friends who, one of them was a seamstress, and she helped with the jack. I had a leather jacket, and I actually took Adafruit was a really, I mean, still is a great popular brand for a lot of DIY stuff. And I know that Limor had this like sewable electronics kind of stuff. You could do the conductive thread, and took the NeoPixel group that they had and sewed them into the back of the jacket. And I embedded a battery pack and a little like wearable kit inside of the inside pocket, and it would synchronize the brake lights with the ones on the motorcycle, and also the indicators and the as well, because you could like change the colors of them. And at that point I was like, okay, well, I'm one step away from being James Bond, so I might as well make it so that wearing the jacket is the key, right? And you just walk up to the bike and it starts, and you just get off and walk away, and it stops, right? So
That's
it
pretty.
was. It was awesome. Yeah, I love that thing so much. Obviously I grew up. I grew up more and had kids, and motorcycling became less of a pastime that felt safe. Reduced that risk.
Mhm.
So I still have the jacket, but I don't ride it as much anymore. Yeah. Um, there was a moment there, I guess, and that as I mentioned, that was like a really tough area to integrate all those things, and that kind of spurred right at the moment there, like the birth of IoT. And I spent probably the next 10 years of my life writing an open source framework called Nerves, which is
Hmm.
for programming embedded systems using the Erlang VM. So you guys familiar with Erlang VM?
I've
Yeah.
heard of it. Yeah, yeah.
Yeah, yeah.
Not used it, but
Yeah, so Erlang was like this like language in a virtual machine. It has a process model, and it was built in like the early 80s to be able to handle actually running on like some of the early telephone switch networks.
Yeah.
And it was, so it was originally made for like building embedded systems. And with Nerves, the goal was to be able to get it so that the Linux machine would just boot basically as the first process instead of like systemd. It would be like the Erlang VM because it had that process model.
Hmm.
And it was a really neat system. We learned a lot from that experience, and some of the great outstanding components of it was that in this case it was using Buildroot under the hood, and that transitioning out of that project. I saw that the great aspects were just that it really decoupled the slow processing loop of building the system from the application development domain. Like basically, you can just consider your running machine to be Elixir or Erlang, and so you could just stay in that quick iteration loop and push things out to the device. That was a really good feature. But then arguably counter to that, we had to manage a lot of different distribution, a lot of different targets with Buildroot, and obviously in my mind the natural transition went to Yocto because there was the layered approach, and for a distro maintainer at that point, it made the choice of using Yocto felt more natural. But we're already pretty entrenched into things there, so I kind of saw that everybody was really moving in that direction. Some of the great benefits that Yocto had of like allowing even the BSP maintainers to have more finite control over their contribution, kind of being up to date and having that ownership, right?
So, what brings to Avocado OS? So, what problems does it solve, and how does it do it?
Yeah, Avocado is that next pathway. I see. I took all of the lessons learned from that experience with Nerves, and really tried to approach Avocado this in this with this mindset, and so even foundationally, we made that big choice to be able to go to Yocto for this. It felt like the necessity to maintain a distribution of that size with a build system that was built in the way that bring everything layered together and from the vendors was a good approach. We carried forward that feeling like you want to be able to have the application development experience be able to run at its own pace and not sort of be bottlenecked, if you will, by systems integration in order to be able to get that cycle put onto the machine. And so we kind of use that as our platform, and then what we did from there was we decided to focus on some key pillars, which is composability, extensibility, and security. And I take a lot of these from a lot of my work inside of the Elixir community, right? These were like foundational elements to what it was like to program in a modern language. And they wanted these were that in addition to like high quality documentation, accessibility, and testing. It really just got me thinking about how when we build embedded products these days, that the operating system itself sometimes can be treated as just this thing that exists alongside of our business logic, right?
Mhm.
It's like something that we just happen to use. But I started to see it more as a core component, and if not just an extension of the product itself,
Mhm.
And when we think about Yocto even as well, like it's a distro builder, and it's really in service of trying to be able to act in that fashion. And so what can we do to be able to kind of like prop this idea up even more under the idea of composability, extensibility, and security? Well, it's to try to make it so that the operating system has, as a framework, a means of being able to fit into the product development lifecycle, even,
Mhm.
right? And if you think about the product development lifecycle, and you even just map that back to application programming, well, then it makes sense to be able to have a documented path towards, like where can I place unit tests, and how do I get them in there that can be run on the end of the manufacturing line while I'm building my product, or how would it interact maybe with some sort of bed of nails programmer? How quickly can I get the programmers to run like that? That's often an underserved area, I think, in a lot of people's product
Mhm.
journey, right? You get
Yeah.
to that point, yeah,
Think
and
about
they're like,
system testing last, instead of first. So I appreciate that. Yeah.
yeah, and it's like for every one product you have to build two, right? Is the kind of the thing,
Hmm.
right? And every CM is different, right? And the way that they're like, I've got some crusty old Windows machine, try to get your software up and running on it, please. And so there's just so many areas, I believe, in that journey that are fraught with just potential error, that if we could just kind of take what we've all learned collectively and normalize that to make it feel like the OS itself is in service of the goal of you building an actual product, instead of
Mhm.
you know um, and offering that as a first class solution. That was like the extension of that good feeling we got from that accelerated application development
Mhm.
line, right?
Hmm.
And so now let me tie it all back together, because we started talking about composability and extensibility, and well, that's the crux, I believe, of being able to do some of these things. But we need to rethink the way that we lay out the disk images, if you will, or the partitions of a system, all the way up through, so that we can have a bit level, like block level influence, to be able to cryptographically just staple pieces together and have them cohesively work in the runtime, in order for us to be able to do things like to reduce the time it takes on the manufacturing line to provision them, right?
Mhm.
Usually that's an online experience. Well, if we can take steps towards composing images, almost like CPIO, right? Like, so like,
Mhm.
like if we can kind of staple and like compose and construct things from the block level, the more we can do that, the faster we can be in manufacturing, the less error prone the systems will be, and so on and so on. And that's really the key and the crux of Avocado. It embraces systemd system extensions in a way that allows us to create deterministic, immutable runtimes in whatever composition we feel, for whatever stage of the product that it's in. If I have a development one, I can add development extensions. If I have manufacturing and provisioning, I can add provisioning extensions. For production, I can have production ones and recovery extensions. And these different modes all kind of work and like produce this experience that's going to help build better products.
So I
So
think, go ahead. One of the aspects that is always, lacking is developer experience. Especially if you see around Yocto, there's a very good release engineering and deployment experience. But developer experience, there are several tools out there. But so, could you talk to like how Avocado solves that from a developer experience point of view, like who's developing applications or maybe part of the system on top of Avocado OS?
Yeah, sure. So we, the way that we provide this is, Yocto has a means of being able to build an SDK already today, right? And
Hmm.
it's the self-extracting installer. So there's even an extensible one as well that takes some great steps forward and making that a little bit more composable as well. Yeah. But so what we're doing is we're a binary distribution. We build the world from Yocto, but we also build the world, an enhanced world of the possible things that you might want as extras in your native SDK. And
Hmm.
instead of installing all of that native SDK at once, which we provide a container runtime in our SDK that runs on your host that would install those packages. But we also let you kind of extend that through there as well. So we'll build all of the different things that you might possibly want for the native SDK, in addition to the runtime that you might install for dependencies that your application needs too, right? And so you're really operating package management at the runtime instead of, at build time instead of the runtime, right? And that way you still produce the deterministic systems and immutability. But you're able to have access to the familiar tools of package management that a developer might desire while feeling around in the dark, especially, right? That coupled with the fact that instead of we can use NFS to be able to get us some quality features. Now, mind you, this is also once again something that Yocto has the capability of setting up and doing. You can mount your entire rootfs as an NFS. It's really cool. But NFS has some sharp edges still, and it can take some time to get set up, right? And we always play that devil's advocate game as a developer of, can I fix the problem faster than I can set up my in the loop environment, right? And in this case, we make it really easy to be able to set up some NFS hardware in the loop mechanisms. And so we're not doing it at the root file system level, right? So I guess just to break it down a little bit more, what you're doing in our SDK is you're installing packages into building an extension sysroot tree that'll overlay at runtime the minimal root file system images that we produce from upstream. We only build for the art binary distribution in our images only what's necessary to boot it, and then everything else that you want to do as customization is installed through the extensions that you include or that you're building. So you're influencing this extension layer that you're building on your machine, and what we do is we NFS mount the sysroot that you're putting together on your host workstation. We NFS that mount that to a directory on the runtime, and systemd sysx will actually take that directory and mount and have that participate as an active extension, which means that's stacked up now in your overlay, and therefore any new packages that you install on the host or remove or anything that you're cross-compiling will just automatically be present on the runtime. So the experience of development is very fast. If you need extra dependencies, it's almost like working on a desktop distro, but without the side effects of long-term drift and mutation. You run those 50 apt-get commands and you don't remember what they were that got you to this happy place. In this case, you're always ready to ship. Those commands are locked into the extension creation, and then from there you can just produce that as an image and build a runtime that's already set up with the seatbelts enabled.
So how does this contrast to Docker? Some people are deploying Docker on their edge devices and then installing applications with that, but this seems a little bit different. Can you talk about that a little bit?
This is the lighter weight. Yeah. Now, mind you,
lighter weight.
Yeah, it makes you think Docker because of the concepts of overlayFS, the technologies that are being used to kind of stack up those layers. But what we found is when it comes to running containers on an embedded environment, it's not as desirable or a good feeling that you get like running containers in the cloud and on a desktop. And I truly believe that's just, it comes down to the idea that containers themselves, they were built to be able to isolate workloads in multi-user environments. And that's not an embedded system, right? An embedded device, it's a single purpose, point thing. It's usually not a multi-user environment. And these days, services like to have their own users and stuff, but still, and what we want there not necessarily is isolation, but we want integration. We want, because that makes it easier to reason about too when things go wrong.
The isolation is a real pain, in container environments sometimes. So I appreciate that you're trying to make things easier in that respect. So that's cool.
Yeah, and also to that point, the isolation mechanism, containers themselves, they don't care about the kernel. That's a feature, but us as embedded developers, we deeply care about the kernel.
Yes,
a lot of our code usually has a very intimate relationship with the kernel, right? And so you find yourself removing the seatbelts. The moment you just type -- privileged, you've just thrown all of the benefit that you could possibly claim out the window.
Sure. Yeah, that's interesting.
So what's other systems you tried? You said it is based on Yocto project. So did you look into, and you briefly touched on, your experiences with Buildroot and then using Yocto. So did you have other thoughts as a baseline for Avocado OS before you were starting? And what were the reasons not to use those?
Well, there's always script land, right?
Mm-hmm.
But I just can't fathom what life would be like having to really be the only one on your snowflake script land that builds that kind of stuff. It's got to be difficult, and you always look around for tools that are going to help. And as you mentioned, yeah, Buildroot was certainly one of them. Um, but Yocto, it it often gets dismissed due to its claimed complexity.
Mm-hmm.
But I truly believe that having experienced death by a thousand paper cuts of maintaining multiple targets with other tools, that the complexity that is introduced via its layered approach, um, as long as things are going right, it's just a super savior of time and energy and effort,
Mm-hmm.
um, especially when building all those targets.
Yeah.
There might be ways we can theorize getting around some of that as we move forward in the future, but this is a complex problem,
Yeah.
and hiding all that complexity is not necessarily the complete solution, right? And
Mm-hmm.
while what I talk about when it comes to like Avocado and the approach, we talked about the developer experience environment. That might sound like we're trying to hide the complexity and the pain from learning that steep learning curve. And I don't want to dismiss the fact that myself too included. I love the Octo. I think that it's a great tool. I embrace that complexity. I don't want to in ways alienate that experience similarly to the people like myself, systems integrators, for example, or even the answer to what happens if we're going chip down.
Yeah.
And so we don't want to build something that hides Yocto completely. That would be a disservice.
Yeah.
And instead, what we're doing is, as an open source perspective, producing our distro using it such that we can always have a great story for the escape patch that creates an experience where systems integrators and rapid moving application development teams can work together and embrace this as a technology. And that the systems integrators don't feel like they're trying to be replaced or in any of that means. No, we understand and appreciate that there'll always be situations with boards where your bootloader needs patches or the Linux kernel needs patches. And we have some answers to, building out of tree kernel modules right in the SDK, or compiling your device tree out of tree in the SDK. But sometimes push comes to shove, and there was some weird bug in a DAC that wasn't touched in a module like forever ago, and you need to introduce some patches while you will await some upstream acceptance. And so we usually advocate in that time for you to just create a small layer for those changes, build just that package that you may patch, and then introduce it back into your own package, private package repository feed to participate in the layer up that we offer in our SDK. That way your application development team can continue to move fast and iterate without kind of being blocked by or having to feel like after the engagement might end, whether maybe that's a development shop or something, that they're being left with a lot of code that they don't understand. It's less scary for them then.
Yeah. So I've heard the term binary distribution. So most of us use Yocto as a source distribution where we build everything, when we build an image. So is your model different from that, or how does that work?
So we use Yocto the same way anybody else really would, but instead of building just what we need to make it work, or the opt-in approach that it offers, we build the world so that we produce the packages, and that's the avenue in which a lot of developers will engage. The SDK pulls the packages at their build time in their build environment, and then composes them together to make those sysroots. And so we are also consuming the source, but there's some caveats, that you have to trade-offs that you have to make. For example, we'll trim up the kernel configurations so that we only say yes to the things that we know the board needs to boot. And we offer integration moments, like in the inner MFS, for you to provide also extensions, the same capability to apply anything early boot or at the root FS level as well. You can everything else that we say that we wouldn't say yes to compile into the kernel, we'll try state to M. So that it gets built as a module, and that way then you'll have access to that repository of kernel modules that you can add and then build it with as well. So yeah.
Okay. So what package format do you use then?
Great question. Yeah, we landed on RPM because it has good multi-arch support, and therefore, while I want to minimize the amount of repositories that we maintain. But as you can imagine, there is a scaling amount of a matrix of complexity that increases the number of repos. Desktop distributions really only care about a handful of architectures with a single distro. But as we build platform to platform, Yocto very conveniently will create and organize the package directory so that it'll have a feed that's or a folder that's containing recipes that may have had overrides when they were built from source for that specific platform. Example of this might be that the NVIDIA Jetson boards, they might patch up containerd if you wanted to run containers, and they have their own version of that. And so when that gets built for that platform, for that target, that repo that package actually gets put into the platform specific repo, right?
Yeah.
And Yocto will also be intelligent enough to divvy up the rest with a number of tunes. So on that same Jetson, you'll see like an ARM V8 tune repo, right? And then you'll have the ones that are just kind of portable and work for all. And since we're building the same point in time of our distro for all these targets, we aggregate the shared ones as the tunes to be able to kind of dedupe some of the package feeds. And what we do when we lay out in our DNF configurations, we're leveraging DNF for the RPMs under the hood. When we structure that, we just set our priorities so that the platform repo will take the highest priority over the tunes, over the all arch and the none. And that affords us this moment of integration, as mentioned earlier, where if a customer has platform specific patches that they're making or building packages on the side, that they can actually introduce their own private repository feed as a highest priority. So they have overarching control to interrupt any of the points of the system that they might need to build special for.
Okay. So I could go on with a lot of questions. So just tell me to stop if this is getting annoying. But how often do you do releases, or how do you keep from having to publish like a million different versions of binaries and stuff like that?
Well, it's a growing problem, yeah. And what we're doing actually right now is we're doing nightly releases for our Edge, what we're calling the Edge release channels, and they have, I believe, a 7-day rolling window. So they're really good for just like development testing, things like that for the Edge repos. So they stay pretty trimmed, which is nice. And we're looking to be able to do probably more of a monthly or bi-monthly release cycle for stable channels. Right now we're in sort of a public beta developer preview mode that we're coming out with today, supporting the Jetson series stuff, the IMX93 stuff, and because every developer has 4 or 5 of them in a drawer, Raspberry Pi, right? And so yeah, we're trying to be able to kind of see what a good cadence feel out that's going to be like. But yeah, we're looking to be able to also then align ourselves with the LTS release cycles for Yocto. We're right now releasing for ScartGap in anticipation of prepping up work for the next LTS that's going to be released. With some caveats that we do backport some additional packages to get some newer versions from WellNASCAR and future the master branches as well. So yeah.
Okay.
So you extensively worked on Yocto on this one. Are there some special things you thought that, gosh, if Yocto had that, it would have helped Avocado? Or generally any pet peeves you have?
Yeah, I've not gotten into multi-config yet, but I'm really excited to, right? I think that's going to be helpful. But the documentation was a little lean. But I believe that we're kind of like at a young place a bit with that in its progression. And to that point as well with multi-config, and this one might just be like an odd choice, be helpful for like people building distros out of it, is that I would like multi-config to apply to the SDK builds. And that currently, as I can see it, there's no real good way, a convenient way for me to build two different SDKs for two different host architectures at the same time with even with multi-config. And I think it's just because there's a little bit too much that's kind of baked into the native SDK class.
Yes.
That kind of like intermixes a bit there. But now once again, like I think that would still be a valid problem case for somebody, a development team maybe that's using Yocto directly and just knows that they have a variety of host machines with different SDK architecture types. Today it's not that big of a deal. I just kind of run two CI builds, yeah, that would be one area where I think some good improvement could be made.
Yeah. I think multi-config is very promising. If you look at even if when you put a system together, there hardly is that you have a single system these days. You have like RTOSes, you have other things. So when you put the full monolith together, it really solves that problem neatly. But I agree. I think there are things that can be brought up to speed with other like uniform, single architectures. Pretty cool. So how do you see, I know you talked about reproducibility and composability, so how do you see the embedded systems of future? What's changed since you have been involved? How is this landscape changing?
I think that what we're starting to see, especially, is that more and more people are realizing that extensibility, composability, like actually deterministic runtimes are paramount to the success of their products.
Mm-hmm.
And the unfortunate side effect really that has occurred is that the silicon manufacturers really have had this dichotomy of choice when it comes to how to advocate that their customers would go about developing things. On one hand, you have desktop distributions that are fully featured. They're very friendly. Developers know how to use them. They have a good, easy, upfront capability to get you to feel successful quickly. And from a silicon manufacturer, that feels desirable. They want to get their customers feeling successfully as quickly as possible. It'll help them be able to make more sales, make their product more appealing. But arguably, those operating systems, they're not geared towards the problems that we face with embedded devices.
Yeah.
Really, the traditional application that might even be lacking from people's mindset when they're using a system like that is things like image-based updates. We're starting to see immutable distros become a thing, which I'm really happy to see, and that'll help alleviate some of that pain. But subsequently, I just don't think that there's a way for them to be able to solve all the problems that embedded will offer. And one that I always point at is, well, in order to run one of those, you need to have full upstream support. And as we just talked about, these heterogeneous architectures that are coming out, the pace of innovation for silicon vendors is such that there's always going to sort of be these patches that are necessary for them to be able to make things work. And it's difficult for them to be able to swallow the pill that says that they have to wait until the kernel maintainers accept those patches for them to be able to sell their silicon, right? And so that's kind of the sticking point on that side of the equation. And then on the other side, there's that, as we mentioned, the saying that Yocto is a steeper learning curve up front, but it does set you up for longer term success, right? You are going to be producing systems with embedded in mind, and you're going to produce things that are going to have better guarantees, better security, better seatbelts.
Yeah.
Right? But it's got that steeper learning curve. And so I think that like as we move forward into the embedded systems of tomorrow, we're gonna start to be able to see things that, like in this case, Avocado's like bridging that gap. It's getting rid of those trade-offs, and it's giving you that fast experience up front, and it's with the long-term support, sustainability for your updates and the way it's organized. And that in order to do that, we're going to need to lean harder into this concept of composability. I think that we're gonna see more and more people start to embrace the tools like Yocto and that ecosystem and step away from desktop-based distributions because they don't lead to longer, scalable, successful stories. And that these more complex environments are gonna always be a thing. These heterogeneous architectures, like
Yeah.
everything's a car now, right? Like we kind of joke in the past, like 10 different computers in your car.
Yeah.
It's kind of like the same thing on a single board now. And so,
Yes.
we're going to step away from that mindset of single device, single firmware, and move into one where it's going to be more of an exposure to the dependencies that comprise it.
Right.
Mm-hmm.
Yeah, that's where I think the multi-arch and essentially maintaining it over like period of time, as you said rightly, that you get up to speed quickly, but then what do you do over a long period of time is what defines the success for that
Mm-hmm.
product.
Hmm.
Uh,
Hmm.
so, how do you see the new kind of AI workloads or robotics and all that playing in? Do you consider that part of embedded, or do you think that's something different? And how does that play into this new landscape?
What this question reminds me of? It reminds me of when the Raspberry Pi came out and people still called it firmware, and there was the
Uh-huh.
whole, is it firmware? It's software now, right? It's such a great debate to have. What is firmware? What is And anyways, how that maps, yeah, the AI workloads being introduced. I mean, it's really a spark of innovation for this that we found too. Is for the last I've been building embedded devices, helping companies for over 2 decades, but especially in the last 5 years or so, so many of the clients that I would engage with would want to introduce machine learning workflows and at least onto their runtimes. There's a whole separate aspect of it being participants in our development workflows, but on the runtimes. And what we saw was the diversity of the team talent pool increase, right? And now when you used to have systems engineers and you used to have application developers, well, now you also have data scientists.
Yeah.
And I think that the gap in knowledge between data scientists and engineers is starting to close more and more to allow us to like really communicate well with each other. But early on, it was tough, and that there was a pretty steep learning curve, such that whatever that data scientist threw over the wall to you to get to run, you just kind of run it because it's your job to optimize it for the edge, but sometimes it would feel overly complex and outside of the domain from traditional embedded or even software engineering perspectives. And we saw that they wanted to run way faster than the application guys who wanted to still already run faster than the systems engineers, right? So breaking that problem apart and making it so that you can have these workflows running at their own cycle rates is what really starts to like key up that innovation and allow more companies to be able to be building products that they want to. I think this similarly resonates with like in the 2010s when we saw kiosks
Yes.
kind of like rise to fame a bit, right? And that arguably was a moment where we had a sustainable growth for the IoT, where companies who don't have access to or don't internally have like deeply technical embedded talent felt empowered to produce these devices and products that met their vision for their company to be able to innovate because they could take and have access to their existing talent pool and just apply them towards that. We're going to see the same thing with AI. Yeah.
Mm-hmm.
Yes. So, what are some of the technologies that interest you looking into future beyond what we have been talking about? Like, are you looking into something entirely different?
I'm wanting to build a lot of interesting projects. I last year I on a whim decided I would build my own closed loop brain computer interface using some components from BCI and from integrated into an Apple Vision Pro. And so the things that interest me are in flux usually,
Yep.
but as I look around in my office as well, they're scattered amongst. But what I'm really interested in is, as we move forward with AI, with the concepts of agentic systems as well, that I believe, we're kind of also in the pendulum swing where things are coming away from the cloud and really needing to be distributed more to the edge for latency reasons, but also because we're literally running out of enough cold air to keep these massive data centers cool.
Mhm.
right? So as that pendulum swings back, we're going to start to see more stuff that gets put down on the edge. And I think that in order for us to achieve this like agentic, like I'm going to have hundreds of agents, let's say, that are operating on my behalf. That workload is going to need to get localized and distributed across a lot of processing power that I might hold amongst a variety of devices or platforms. And when we enter that world, we're going to need to approach the trust of security of computation in a new way. I'm really excited for the work that ARM is doing with the confidential computing extensions
Yeah.
in V9.2, I think it is. And the reason I'm really excited about that is because Intel tried, AMD tried, and they tried using extensions, and arguably even the way that blockchain companies, I know that's a left field, right? But the way that blockchain companies tried to get adoption was they built frameworks that they tried to get everybody to build within. And what I think is the winner here with ARM's confidential computing platform is that it uses traditional VMs and then offers the security boundaries at the chip level to segment the memory and encrypt it and stuff. And that's highly approachable for people to be able to adopt, because you're not forcing me into using your framework if it's going to be
Yeah.
around. It's kind of like, hey, have you ever built a VM in your life? They're back. Yeah. So I think that's going to be really cool, and what we start to be able to see with like compute placement, I think that the vision I see is that all of the computing power of these chips are going to be commoditized in a way where you'll feel fine being able to place compute workloads via VMs in those secured environments, and that'll actually let this future vision of us being able to run thousands of these AI agents like around us to actually grow and flourish, right?
Yeah. Pretty cool. So, what does your you know environment look like? What kind of like Linux distros you use or editors, or what does your development environment look like?
That's a fun one as well, because I have I traveled with this last week. I have a laptop that I have. It's got one sticker on it. It just says NVIDIA. And the only reason I have that laptop with that sticker is because it specifically runs Ubuntu 2204,
Hmm.
because NVIDIA. And they have very strict requirements over the host tools that they have to that distro that they were tested. I'm hoping that starts to crack open more, and I hope that, because 2204 is feeling quite dated in its
Yeah.
tools. And over the years, I've usually gravitated more towards like Ubuntu releases and stayed with LTS releases as well. But I have to admit, I have been for a long time, since early career, a bit of a Red Hat fanboy.
Mm.
It died off a little bit, I would say, after the acquisition,
Mm.
but still, I run Fedora 42 currently on my workstations, and when I need to be able to build, I'm containerizing workloads to run under like an Ubuntu
Mm.
domain for that. But yeah, I'm really happy with building Yocto a lot. By the way, I'm sure it can be a beefy task, and so
Yeah.
I just treated myself to a new Threadripper. I got them 64 threads, and so
Mhm.
I'm ripping through distros pretty quick. It's fun, and I like Fedora just because I always have access to good, high quality, like latest tools that seem to always be working. Like I've not had problems with that distro. It's been an enjoyable experience. So. Oh, and my editor. Well, that's a personal question, isn't
Very.
it?
Indeed.
Yeah. I'll look. I'll admit. I I use Vim to get around. I'm not super in depth in the lands of Tmux, but I'm familiar with those tools. But they're not my first choice. I have been a VS Code user for a while. I do like graphics.
Yeah.
Mhm.
I'm a man who enjoys some fine graphics.
Hmm.
And more recently, I have been using Cursor, which is
Yeah.
enhanced with some AI tooling. And there's been a lot of blog posts I've read about the usual suspects of executive teams versus developers shouting at each other over why they should be using it or why they shouldn't be using it.
Yeah.
Choose your side.
Mm.
But as long as you can understand and like kind of connect with and know how to be able to minimize the question of work that you're asking for, you can usually coax it into giving you some really good direction and results. I don't lean on it 100% of the time. Its use throughout Yocto is pretty good, but it can spiral out of control and do some weird things. Sometimes it reaches for the Python backdoor, and you're like, this does not look like a recipe anymore.
Yeah, that's cool. So you are using the AI coding tools.
I am.
Yeah. I've been using Claude Code some recently, and pretty impressed with what it can do. So
it's really good for keeping me honest and putting docs where docs are necessary, right? Sometimes when we do work in Yocto too, like the reasons why you do something can be quite hidden from the code itself. Yes. Contrary to like, and I say that a bit cheekily to say it's self-documenting, the programmers who say it's self-documenting, but I think that that's even a further gap in the Yocto sense. Sometimes there's little tweaks that are made that aren't necessarily immediately obvious,
Yes. Yeah, in the end, it's all about productivity, and I mean, if it is helping you to improve your productivity, nothing like that.
Yeah. Absolutely.
And there's a lot of ways to use these tools. I've been thinking recently, like a lot of people just write into a chat window, write me a program that does this. But why not do the change log first and tell the tool, hey, go look at the change log and do what's in the change log, and kind of flip this whole thing on its head instead of and it would help the thinking part and so on.
Yeah, that's a great approach. That's also the document-driven development approach. Right. Yeah. So you give it the boundaries, and then it knows how to be able to act. And also, as mentioned, there's some people that put it and copy and paste stuff between the chat window and the code itself. It wasn't until taking the step where I gave it more deep access to the overall context of the code via cursor, or even like you're saying with Claude Code, where it became even more helpful, because you can more easily direct it, and then you also spend less time copying and pasting back and forth between windows. It's like feels like SD card swapping, doesn't it?
Yeah. One thing I did this morning was I needed to run a quick thing where I needed to use some Google APIs, and I despise working with Google Cloud permissions and all that stuff. So I told Claude Code, I said, run gcloud and set up a credentials file to access these APIs. It took 10 minutes, but it got it, and it would have taken me a lot longer to figure that all out. So
I imagine at this point now it's that same tool is being used to write the tools that agentic systems are being used, right? Like that's like that enhancement. Like you need to know how to edit a file with Git. There's like a tiny little bit of code, and then that enhances that agentic mechanism with that tool, and it uses that as its disposal. AI training AI.
Yeah. So I'm curious, do you still do any Erlang in your systems now, or what programming languages do you use to implement Avocado stuff?
There's a special place in my heart for Erlang. There always will be. The process model is wonderful. Joe Armstrong, I've had several great occasions with him. And yeah, there's a lot of stuff that we still have that we do in Erlang for projects. However, from the Avocado perspective, one of the other foundational pillars that we have for development of it is to try to introduce as little new code as possible, right? And I find this to be key, because we're all human. We all make mistakes. The more new code that's not been vetted in production that you introduce, the more of an opportunity there is for error. So as of today, there outside of the development experience, and even that is just containers, it's just DNF, it's just that. There's no Avocado code in the runtime that's getting in the way of anything. We do have a CLI that runs on your host machine to add enhancements to the development environment, but our main focus is developer sugar. And we're basically just trying to be able to take a lot of the accepted best practices and even reach for some newer technologies that have been created in service of making the cloud and server architectures more sustainable. Things like system extensions and configs were originally designed for these places in mind, but had great benefits if we were to just apply them and rethink the way that we construct embedded systems with them. And so therefore, everything that we're kind of doing is built using these already accepted and adopted upstream patterns.
Mm-hmm.
And it's just a matter of rethinking the way we approach the systems and adding a little sugar to make that experience enjoyable.
Wow. Okay. That's fascinating. I was just wondering if you're like writing a pretty big layer in Avocado, but it doesn't sound like that. So that's very interesting. Okay.
The layer in Avocado is it's mostly BB appends to just enable some package features and stuff like that for existing recipes. Yeah. So.
Yeah. Very nice.
So any reading recommendations that you've been reading, any podcast or any YouTube channels that you would like to share for the listeners?
Yeah, I aside from reading random research papers, I've, as mentioned, I've gone down a rabbit hole of exploring a little bit more about the mind.
Mm-hmm.
And that led me to read a book called The User Illusion, which I just cannot recommend enough. The author does a fantastic job setting up their thesis as to make this comparison to this concept, the user illusion, which is actually founded in computer science, computer programming, of describing that the user interface that a user of the computer is observing the complexity of the computer through is a minimized subset of all of the complexity under the hood, right? So it's this like watered down view, and he maps this concept as to human consciousness, and that our conscious brains that are the ones that are in what we perceive to be actual reality is only experiencing a fraction of the stimulus that's occurring in the world around them. And a lot of our bodies are reacting to things using our non-conscious systems, or the way that our bodies and minds have been programmed over the years. Very much so akin to the idea that a musician or an athlete or somebody who is doing something of great talent is not actually doing it consciously. And I can tell you from experience in performance and playing drums that the moment I think about what I'm doing, I'm screwing up. And so, we've all had these feelings of being in flow. We know that we desire to get to that place. And this book is really good at exploring those concepts, but rooting it in science, and has a great amount of history to it and lessons of all the studies that occurred over time to make it this thesis come through. And it's a delightful read. Yeah.
So to wrap things up, do you have any advice for young people, Justin?
If you've got a crazy idea and that's going to lead to you learning something new, go for it. If there's so many new programmers that ask themselves, I want to learn this language, I want to learn how to do this thing, but I just don't know how to get started. What books should I read? What sites should I go to? And my avocation usually always is to find something that you love and figure out how to be able to do something different with it using that language or using that technique. And this all stems back to my love for motorcycling and making that bike start from my phone. And along the way, I learned a lot about computers. I also learned a lot about how to hotwire a motorcycle. But all of that is knowledge. And the more things that we can do, we can unshroud, the more we can feel like we can get to where the edge of innovation actually is. Because you shouldn't be ashamed to reproduce somebody else's idea in service of driving towards your own. When you get there, it'll be sad, maybe lonely a bit, because you're going to want somebody to look at you and go, this is new, this is original. But if it is, it truly is, it's not really going to be somebody near you to be able to tell you those things. It's something that I've always kind of strived to be able to get to, but I think that the challenge is that you just always have to be able to bring the friends along the way, get good colleagues, interact with others in a desirable way, and just make sure that you Don't think too hard on whether or not your idea is stupid. All ideas are great ideas, especially if you can vocalize them, get others involved, and get people excited to be able to go along and participate on that with you.
Yeah, appreciate that. Anything else, Cam? Or?
Yeah, I think it was awesome conversation. So I think thanks, Justin, for enlightening us with all stuff that you have been doing so far. It was very entertaining. I hope everybody will find it as such.
Thank you so much.
Yeah, we appreciate having you on, and we also appreciate our listeners and the feedback you give us. If we really appreciate hearing from you, what resonates or what topics you'd like to hear about in the future. So appreciate it, y'all, and until next time. Thank you.
Thank you.